We're surrounded by these digital brains every single day. They're in our pockets, on our desks, even in our cars. But let's be honest, how often do we really stop and think about what's actually happening inside that magic black box? Well, today, we're going to pull back that curtain and really demystify the whole process, from the inside out. So, have you ever really thought about it? You move your hand, a little arrow moves on the screen, you click, and an entire world just opens up. A game, a browser, you name it. That one simple action kicks off this incredibly complex, lightning-fast chain of events. It feels like magic, right? Well, let's follow that click and uncover the secrets of your computer's digital brain.
All right, so first things first, the basic idea. Before we get into all the nuts and bolts, let's just boil it down to the simplest possible concept of what a computer even is. And you might be surprised at just how simple it is at its core.
And really, that's it. I'm not kidding. At its heart, this is what every single computing device does. It doesn't matter if it's a massive supercomputer or your phone ordering a pizza. It's all just this constant cycle of taking information in, thinking about it for a split second, and then giving you a result.
It's this simple three-step dance: input, processing, output. And that is the foundation for absolutely everything. You type something on your keyboard, that's your input. The computer turns those keystrokes into words on a document, that's the processing. And then it shows up on your screen, and that's the output. This simple little loop is the key to understanding everything else we're going to talk about.
Okay, so we've got the basic idea down, but what about that processing part? What's actually happening in there? To figure that out, we've got to look at the hardware. And the best way to do that is to think of it like, well, like the anatomy of a digital brain.
First up is the absolute star of the show, the CPU, the central processing unit. If the computer is a brain, then the CPU is the part that does all the actual thinking. It's the engine, the workhorse, it runs all the calculations, it follows all the instructions, and it makes all the decisions. Every single thing you tell your computer to do is ultimately handled right here.
Now, a brain can't just think in a vacuum, right? It needs a workspace, a kind of short-term memory for what it's doing right now, and that's RAM, or random access memory. The best analogy is to think of it like a workbench. You don't keep all your tools for a project in the garage, you bring out what you need and put it on the bench. The bigger your workbench, the more stuff you can work on at once, and that's why more RAM makes your computer feel faster when you have a bunch of apps open.
But here's the catch with that workbench. What happens when you turn off the lights for the night? Poof! It gets cleared off. That's where your storage comes in, your hard drive or your SSD. This is the brain's long-term memory. This is the filing cabinet, the library, where all your programs, all your documents, and all your photos are stored safely and permanently, just waiting to be pulled out onto the workbench when you need them.
So let's just put these side by side for a second. RAM is your workbench. It's incredibly fast, but it's temporary. The technical term is volatile, which just means when the power goes out, whatever's on it is gone. Storage, on the other hand, is your filing cabinet. It's a bit slower to access, but it's permanent. It's non-volatile. You absolutely need both of them working together perfectly.
So, how did all this stuff get so ridiculously small and powerful? I mean, computers used to take up entire rooms. Well, a lot of it comes down to a famous prediction made way back in 1965 by a guy named Gordon Moore. His idea, which we now call Moore's Law, basically predicted this insane exponential growth that let us shrink a computer the size of a building into the smartphone that fits in your hand, all while making it millions of times more powerful. It's wild.
Okay, quick recap. We've got a brain, the CPU. We've got its short-term memory, the RAM. And we have its long-term memory, the storage. Awesome. But how does this brain actually sense anything? How does it interact with the outside world? With us?
And this takes us right back to where we started, input and output. A really great way to think about these is as the computer's senses. Input devices are like its ears and hands. They let it take in information. And output devices are like its voice and face. They let it communicate back to us.
It really is a simple idea, right? A keyboard sends signals into the computer. That's input. A monitor takes what the computer did and displays it out for you to see. That's output. A mouse, a scanner, a microphone, all different ways of giving the computer input. A printer, speakers, headphones, all different kinds of output. See? Simple.
So, we've covered the physical body, the hardware, the brain. But a brain, no matter how powerful it is totally useless without thoughts, without instructions. So now it's time to talk about the non-physical part, the part that brings it all to life, the ghost in the machine.
And I'm not kidding. Without software, your computer is just a very, very expensive paperweight. Software is the set of instructions that tells all that powerful hardware what to do. It's the intelligence, the magic spell, if you will, that actually animates the physical brain.
And it's not just one big blob of code. Software works in layers. So at the very top, there's you, the user. You interact with your apps, your browser, your games, whatever. That's the application software. But here's the thing. Those apps don't talk directly to the hardware. No way. They have to go through a middle manager. And that manager is the operating system, the great translator that gives the final commands to the machine itself.
The operating system, like Windows or Mac OS or Android, is the master controller. It's the boss. When you turn your computer on, the OS is the very first thing that wakes up. And its job is to manage everything. The CPU's time, the memory, all the input and output devices, all your files. It's the conductor of the entire orchestra. All right, we've covered a lot. We've got the basic idea, the brain, the senses, and the ghost in the machine. So now for the grand finale, let's put it all together. Let's trace the complete journey of that single mouse click we talked about right at the very beginning.
Okay, you ready? Here we go. Step 1, you click the icon. That's the input. That signal zips over to the operating system. The OS says, hey CPU, wake up, we gotta launch this program. The CPU then goes to the filing cabinet, the storage drive, and grabs the program files. Then it throws those files onto the workbench, our short-term memory, the RAM. Once it's on the workbench, the CPU gets down to business, processing all the program's instructions line by line. And finally, bam! The result is sent to your monitor as the output, and the program window magically appears. And all of that happens faster than you can even blink.
And that, right there, is the whole takeaway. A computer isn't just a collection of independent parts in a box. It's a deeply interconnected system. Every single thing you do, every click, every key you press, it's all part of this incredibly fast, perfectly choreographed conversation between your input, the OS, the CPU, the memory, and the output, all working together in perfect harmony.
So I want to leave you with this thought from one of the fathers of computing, Alan Turing. We've just walked through how a computer is really just a machine that follows instructions very, very fast. But as these machines get exponentially more complex, well, where's that line? Where does super complex processing end and genuine intelligence begin? It's definitely something to think about the next time you click an icon.